In this video, we're going to switch gears a little bit and we're going to talk about some specific appliances, and we're going to start with the domestic refrigerators. Now, there isn't much of a difference between the commercial stuff we've been talking about and domestic. It's just more compact and it's a little bit more difficult to service. So we're going to talk about this from a systematic standpoint. In other words, everything works together rather than a component by component standpoint. So specifically here, we're talking about domestic refrigerators. Now, when we take a look at a refrigerator, we have to realize that heat enters the refrigerator by conduction, convection, and the introduction of warm food. The warm food in the box raises the temperature. Air in the box is circulated over the cold coil. Air in the box transfers a sensible and latent heat to the cold refrigeration coil. The evaporator dehumidifies the air, causing frost to accumulate on the coil surface. So when we take a look at the domestic refrigerator, we have the freezer section and the refrigerator section. Might be reversed now. Lots of new models are coming out. But inside of this, we have a lot of parts that have to be looked at. A domestic refrigerator is not an easy thing to service because the amount of different temperatures, the amount of different humidities, and the amount of different parts that are important to look at. Very specifically, we have to keep an eye on the gaskets all the way around. We have to keep an eye on the ice buildup in the freezer compartment because, believe it or not, in most refrigerators, unless you get into the newer higher end models, the freezer compartment is what supplies the cold air down into the refrigeration compartment. There's a fan that blows back and forth. So the load on the system increases as warm product is added to the box. Heat is also introduced to the box when the doors open through the gaskets that seal the box, and heat infiltration increases the temperature of the air inside the box. There's a lot of ways for heat to get into these refrigerators, specifically if they're sitting in an unconditioned space. So one of the earlier types of evaporators is the natural draft evaporator. It's normally of the stamped plate variety. In other words, it's stamped. And then there's two plates that are put together to create the channels that refrigerant flows in. Product in the frozen food compartment could be in direct contact with the evaporator. Evaporators can have manual or automatic defrost. Most evaporators do have an accumulator at the outlet. That's it. Basically to protect the compressor. Evaporators are not equipped with air filters in refrigeration. So this is an example of a stamped plate evaporator. Okay, it's the freezer compartment. You see them in the top of the little refrigerators. Sometimes they're the same way in the bigger ones. Okay, there's a cap tube that comes in and runs through the plate that the food is sitting on in the freezer. The food is frozen by that, and then the cold air also circulates inside the freezer and eventually into the refrigerator. So there's two ways for evaporators to defrost. One is manual defrost. Unit must be turned off and emptied. Room heat, a pan of water or small heater is used to melt the accumulated frost. You'd never want to use sharp objects in a freezer to remove frost from an evaporator. Just not a good idea. Automatic defrost is accomplished with internal or external heaters. Sometimes we use hot gas, and we also could use electrical heating elements. How not to remove frost. Okay, don't use serrated knives or coils. These things are aluminum. A knife will go directly through. The compressor, just like any other compressor, pumps heat-laden vapor refrigerant from the evaporator to the condenser. Usually, they're hermetically sealed, reciprocating or rotary variety ranging from 1/10 to 1/3 horsepower. They're located at the bottom of the unit for most refrigerators. There's a few that are at the top. It's the higher end, way more expensive ones. They have oil cooler lines, and refrigerant lines connect to the compressor are often made of steel or copper. Be careful if you ever have to weld in or braze in a new compressor. You might have to use brazing paste because there's sometimes steel lines. The condenser is an air-cooled variety. It could be natural or forced draft. Natural draft condensers are located at the back of the unit and they must have proper airflow across it. Forced draft condensers are usually located under the unit at the back. They must have a set air pattern. So this is a natural draft condenser, okay? Basically hot air rises, cool air comes in and comes up the coil and just flows across. You have to have air circulation behind these units. So when a unit goes into defrost, it's going to create water called condensate. Domestic refrigerators are low temperature appliances. Frost accumulates on the evaporator coil. The coil must be defrosted. The compressor and condenser help evaporate the water that accumulates during defrost. The defrost water pan should be periodically cleaned because it will build up what we call slime. Okay, so if you take a look here, we have our condenser coil up the back of the refrigerator, but our discharge line comes out of the compressor and runs across the bottom of the drain pan. This is an extremely hot line. It will actually help evaporate off any water residue that's sitting in that drain pan. However, if this line is steel, it has a possibility of rusting out because steel will rust. So it's one place to check if you ever have leaks in a system. The compressor oil cooler will help keep compressor oil cool. The line leaves the compressor and makes several passes through the condenser and then returns to the compressor. Air passes over the line just as air passes over the coils of the condenser coil. Oil cooler lines are closed loops. So we might have an extra line at the back here, okay, along with the condenser. It's going to be two lines coming out of the compressor, and all it does is circulate the oil through to help cool the oil in there. Domestic refrigerators most often use cap tubes for metering devices. And again, there are some exceptions with the newer high-efficiency refrigerators who are using EEVs, electronic expansion devices. Cap tube is usually fastened to the suction line for increased heat exchange rate. The cap tube can also be run inside the suction line. Refrigerant flow through the capillary tube is determined by the length of the tube, the bore size, that's the hole in the center, and the pressure difference across the tube. It's designed for indoor operation. So again, if we have a suction line, we might have the cap tube running around it, or less often, we might have the cap tube running inside of it. What we're trying to do here is actually two things. We do boil off any liquid that's left in that suction line coming out of the evaporator, okay, because the cap tube is a little bit warmer. But in the process, we actually cool the liquid refrigerant in that cap tube. It's an efficiency thing. Okay, so again, we have a cross section, we have the suction line, and then the cap tube is actually brazed or soldered to the outside of the suction line. Okay, and the heat leaves the cap tube, and heat always moves from a warm to a cool space. Heat is transferred from the refrigerant in the cap tube to the refrigerant in the suction line. Now, again, just note, those arrows are heat arrows. It's not actually refrigerant that's going from one to the other. The modern refrigerators have a magnetic seal gasket material around the door for a better seal. Condensate flows from the box through a trap to the condensate pan. The trap prevents air from entering the box. Different compartments can be maintained at different temperatures. Some units are equipped with ice and water dispensers. Wiring diagrams a lot of times are permanently attached to the unit. Diagrams can be pictorial or line variety. The components controlled in a domestic refrigerator: you have your compressor, you have your fan motors, you have heaters, you have lights, you have an ice maker, and you have defrost components. So this is just an example of a wiring diagram for a domestic refrigerator. Okay, note there's an ice maker, which has a water solenoid. You have your door switch controlling your lights inside. You might have an energy saver switch that if you turn that energy saver switch to energy saving mode, it's going to turn off the mullion heaters. Mullion heaters are the heaters that run around the door openings to prevent frost and condensation buildup. You have your thermostats, you have your defrost timer. Okay. This is a cumulative run defrost timer because notice the motor turns off when the thermostat is not cooling. You have a defrost heater. You have evaporator fan motors. The evaporator fan will shut off when the unit is in defrost. You have a compressor, you have overloads, and you have a current coil start relay. The compressor is controlled by a line voltage thermostat. The thermostat closes on a rise in box temperature. So it's a cooling thermostat, close on rise. Passes power to the compressor when it's closed, has a remote bulb and is field adjustable. Normally they do not have a numerical temperature scale. The remote bulb contains a volatile fluid that pushes against the diaphragm in the thermostat to close a set of contacts. There's a compressor start circuit. It's designed to help the compressor start. The starting components give the compressor additional starting torque. The circuit often consists of a relay and a start capacitor. So a lot of times these motors are CSIR. Okay, capacitor start induction run. Some units use a positive temperature coefficient known as a PTC start relay. The resistance varies with the temperature. As the temperature increases, so does the resistance. So this is an example of a current coil start relay. Okay, when the thermostat calls, there's a very high starting amperage on the coil, which is, believe it or not, in the run winding. It's in series with the run winding. What that does, it closes the contacts and pulls the start winding into the circuit. As the running amps drop as the compressor is started to run, the coil will become slightly less energized, have less of a magnetic pull, and will allow the start contacts to open. And that will pull the start winding out of the circuit, and the compressor will continue to run on the run winding by itself. This is called a current coil relay because the coil is very heavy gauge wire, and it's more susceptible to current rather than voltage. Sweat prevention heaters are designed to keep the refrigerator cabinet above the dew point temperature. Cabinets will sweat more when the humidity level is high. Small wire heaters are mounted within the cabinet walls. Some units have manual switches to turn the heaters on and off. Okay, refrigeration fan motors are also there. You have an evaporator fan motor. It's connected to a small squirrel cage blower. It runs continuously except when the unit is in defrost. It's usually an open type motor. You have a condenser fan motor. It's connected to a propeller type fan. It's usually a shaded pole motor, and it's located under the refrigerator at the back of the unit. Sometimes we have ice maker operation. It's located in a low temperature compartment, the freezer. Water flows to the ice maker, is solenoid controlled. Water flows to fill the ice maker tray. A timer gives the water ample time to freeze. The ice is then harvested by either twisting the tray or by heating the tray to free the ice. Ice making sequence is often time controlled. Domestic appliances are not equipped with service ports. Installing gauges is not necessary and should always be a last resort. The refrigeration charge in these units is what we call a critical charge. They are very specific down to the ounce of refrigerant put into these systems. You should only install gauges if there's a leak or when repairing the refrigeration circuit. Again, it's a last result. Use process tubes for taking pressure readings. Process tubes can be pinched off when completed and soldered. If there's a low refrigerant charge, there's a leak. The leak should always be located and repaired. One method to determine if the charge is correct, you can turn off the unit for about 5 minutes. Turn the unit on while touching the outlet of the evaporator. If the line gets cold for a short period of time, the charge is most likely correct. If a low charge is inspected, gauges can be installed. And again, you will have to use a piercing type gauge connection or access valve in order to install your gauges. And then once installed, you're going to have to braze in a Schrader valve so that you can work in the refrigeration system, and so it will be leak free. Piercing valves leak. If the refrigerant is overcharged, okay, we have a couple different issues. Forced draft condensers are more efficient than natural draft condensers. Systems with forced draft condensers operate with lower head pressures. The head and suction pressures of a unit will be higher during a hot pull down. In other words, if you have excessive load, either because it hasn't been running or introducing a lot of product. If the compressor sweats around the suction line, there's most likely an overcharge. Now, overcharges don't happen on their own. They're caused by technicians. So just be very careful. If you ever have a leak in a domestic refrigerator, the best thing to do is evacuate any remaining refrigerant, fix your leak, pressure test, do a soap bubble check to make sure you have no more additional leaks, and then once you have the system back in a vacuum, weigh in the proper charge according to the data plate. That is the only correct way to charge domestic refrigerators. Domestic refrigerators only hold a few ounces of refrigerant, so even a small leak will prevent the unit from operating efficiently. Leaks are best found in the shops. Small leaks are difficult to locate in the home. Very small leaks can be found with high-quality leak detectors. Evaporator leaks in the aluminum evaporator are repaired with epoxy. Soldering aluminum evaporators doesn't work well. It's not practical. They'll melt. Always follow the manufacturer's instructions before attempting to make epoxy repairs. The area around the leak should be cleaned well before attempting to make a repair. Pulling a slight vacuum in the system while making an epoxy repair can help pull a small amount of epoxy into the leak, and it will create a stronger bond. Refrigerator condensers are often made of steel. Leaks usually occur at the ends of the coil where the coil connections are made to the rest of the system. While operating, units lose refrigerant faster through high side leaks than low side leaks. Solders with high silver content are best for repairing leaks in steel tubing. Interconnecting piping leaks can be very difficult to repair. The evaporator may have to be removed. It is often more economical to replace the entire unit. Leaks within fiberglass walls are often caused by electrolysis. Flare unions can be used on aluminum and copper joints. If one leak is found, there are most likely others. When you have to change out a compressor in a domestic unit, use the exact replacement whenever possible, identifying all tubing connections before removing the old compressor from the unit. Refrigerant should be recovered from the unit and not just dumped. Remove piping connections from the compressor using a tubing cutter or a torch. Clean all tubing ends and compressor stubs. Add process tubes and a liquid line filter dryer. Evacuate the system after leak rechecking and repairing. Removing Schrader pins or stems and valve depressors will speed the evacuation process. Just remember to put them back in. Moisture may be trapped under the compressor oil. Use full-size gauge connections on both high and low sides. Allow the vacuum pump to operate for about 8 hours. Perform triple evacuation whenever possible. Minimum vacuum should be about 500 microns. Capillary tubes can develop leaks when they rub against another surface. Cap tubes are delicate and have to be handled very carefully. Capillary tubes should be cut with a file, and you need to take real care to protect the bore. That's the center portion, the hole down the capillary tube. It's very, very small. Cap tube sections can be joined with a section of larger tubing. Use as little filler material as possible when brazing. Cap tubes can be replaced if necessary. So if you have a leak in a capillary tube, use a file to cut through the cap tubes on both sides of the leak point. Don't cut all the way through to the bore of the tubing. You'd use the file to create a spot where you can snap the tubing. Repeat the process on the underside. Okay, so you have a look like that. And then what you can do is gently bend the tubing to break off the damaged portion of the tubing. Notice that the hole in the middle, or the bore, is still intact. You then take a larger piece of tubing, insert both ends of the tubing to be joined in the small section of larger tubing, crimp the larger tubing around the two ends of the cap tube. Make certain the two ends of the cap tube are not damaged. Okay, when brazing, use as little filler material as possible. Make certain the ends of the cap tubing don't touch. Okay, so we want them separated inside the larger piece of tubing. Before condemning the compressor, if you suspect you have a bad compressor, check the door gaskets. Check for excessive load on the box. Check for a leaking hot gas solenoid if you have hot gas defrost. Check for improper condenser airflow, including if the condenser is clean. Use manufacturer's guidelines when evaluating the compressor, and always check the compressor amperage. Domestic refrigerators are just a lot of parts in a small space. So you'll get to a point with them where it's not easy enough to repair, like anything that's in the cabinet itself, okay, between the walls of the cabinet. To repair that, it's usually better just to replace the refrigerator. So always when you're dealing with a customer with domestic refrigeration issues, always take a look at the cost of repair versus replace and give the customer both options.